The eruption of Mount Tambora in Indonesia in April 1815 caused the so-called year without a summer in 1816 over many parts of the world. At the regional scale, Europe witnessed a more than 2 degrees Celsius colder climate. The annual mean surface temperature over Asia decreased by about 0.7 degrees Celsius, which increased droughts and famines. As the scientific reports about the impact of volcanic eruptions on climate became more widespread, people thought that volcanic eruptions would result in surface cooling significantly. However, they failed to notice that the mass of sulfur dioxide injected by the volcanoes was the main cause. The volume is not enough to have significant impact on the global climate. Volcanic eruptions resulting in decreased global surface temperature, suppressed global water cycle, sea surface temperature rising similar to El Niño, and also weakened monsoon circulation. The impact of a single volcanic eruption on the surface climate is generally limited to less than 5 years and most evident in the following 1 to 2 years. The land surface temperature returns to normal gradually as the volcanic aerosols dissipate. According to the historical records, volcanoes with a volcanic explosivity index of 4 or above have a remarkable impact on the current climate. There are more than 800 active volcanoes in the world today, all of which are potentially dangerous, such as Mount Kilauea in Hawaii, Mount Lucky in Iceland, Mount Agung in Indonesia, Mount Fuji in Japan, and also Mount Tonga in China, etc. The answer is yes. That's when Earth system modeling or climate system modeling becomes handy. Is in fact not a wild idea, as it may look. Some scientists did suggest injecting sulfide aerosols precursors into the stratosphere. It's a means of what we call geoengineering to cool the planet and reduce global warming. But the decision to implement such a scheme would require a comparison of its benefits, dangers, and the costs to those of other responses to global warming, including doing nothing. A book named Volcanoes, written by Peter Francis, is recommended. There is also a documentary named Earth, The Power of the Planet from BBC, and of course, our latest article discussing the impact of the recent Tonga volcano, which was published in AAS. The answer is atmospheric science, and especially meteorology. Meteorology is the science of the atmosphere, embracing both weather and climate. It's concerned with the physical, dynamical, and chemical state of the Earth's atmosphere, and with the interactions between the Earth's atmosphere and the underlying surface, such as the ocean and the land surface. You can read a book named An Introduction to the Dynamical Meteorology, written by Jim Horton. Thank you for the time. Feel free to leave feedback and comments.